Welcome to lesson 6.5, angles of polygons. The polygons that we're going to be working with in this lesson are triangles. And one of the theorems that they give us, we remember that a triangle has 3 sides and 3 angles. And the first theorem that they give us is theorem 6.16, and it says the sum of the measures of the angles of any triangle is 180 degrees. So that means if I add up this angle plus this angle plus this angle, it will equal 180 degrees. Okay, so I've given you guys a few different kinds of triangles. Here's an equilateral. Here's a isosceles right triangle, like a scalene right triangle, an isosceles triangle, and 2 scalene triangles. And we're going to see how this works. Okay, so I have this equilateral triangle. And we can see that equilateral triangles are also equiangular. Triangles that have equal sides also have equal angles. Okay? If I add up all 3 of these angles, they're going to equal 180 degrees. And since all of these angles are the same, I'm going to call this one angle A. I'm going to say it's like having 3 angle A's because they all match. I'm just going to divide that by 3, and I get the measure of angle A equals 60 degrees. Okay, so this one is 60, this one is 60, and this one is 60. Okay, here I have an isosceles right triangle. I know it's an isosceles right triangle. An isosceles triangle has 2 sides that are equal. These angles are equal, so that means these 2 sides are equal. I know that this is 90 degrees, but I don't know how much these other 2 angles are. Well, I know that 90 degrees plus these 2 angles, so 2 measure of angle, I'll call this angle B, equals 180 degrees. Subtract 90 from both sides. I get 2 times the measure of angle B equals 90, and I'll divide both of those sides by 2 to get the measure of 1, and that gives me 45 degrees. So I know that this is 45 degrees and this is 45 degrees. Okay, and this one I have another right angle. I know that this is 90. This one here is 30 because it's written in, so I can say 90 plus 30 plus the measure of angle C equals 180 degrees. Call that C. 120 plus the measure of angle C equals 180 degrees. Subtract 120 from both sides. And I get the measure of angle C equals 60 degrees. Okay, see how that works? All right. Here I have an isosceles triangle, but I don't know the measurements of any of the angles. So if I don't know the measurements of any of these angles, I can't figure out what the measurements of any of the angles are. If I have the measurement of this angle here, I can figure out these 2, and if I have the measure of one of these, I can figure out the others as well. So I'm going to start out and say this one is 70 degrees. If I know that this is 70 degrees, then I know that this one is also 70 degrees. 70 plus 70 is 140. I have 140 degrees plus the measure of angle D, call that D, equals 180 degrees. I want to get the measure of angle D all by itself, so I am going to subtract 140 from both sides using the subtraction property of equality. Okay, so since when these are 70 degrees, I know that the measure of angle D is 40 degrees. Okay, now if I knew what the measure of angle D was, if I knew this was 40, I could also do it. Let's say that I don't know what these are, but I do know the measure of angle D. I could say the measure, 2 times the measure of angle, we'll call this E. E plus 40 degrees equals 180. And I could subtract angle D from both sides. Bring this down. 2 times the measure of angle E. Because these are equal, they are congruent, so they're equal. That's why I'm saying 2 times the measure of angle E. 180 minus 40 is 140 degrees. Divide both sides by 2. The measure of angle E equals 70 degrees. And that's exactly what we started out with, was that was 70 degrees. Okay, so you can do it either way. With scalene triangles, we need to have the angle measure of at least 2 of the angles. Otherwise, we don't know what these angles are going to be. So what I know here is that if I add angle 1 plus angle 2 plus angle 3, it's going to equal 180 degrees. Okay, so I would have to have maybe, this could be like a 100-degree angle, and this could be 20. So if this is 100 plus 20, that's 120. That would make this one 60 degrees. Okay, but this would have to be given to me to know what this one is. Okay, and the angles for this type of scalene are also going to equal 180 degrees. Okay. Another thing that they tell you in the chapter is that for this type of triangle, a right triangle, actually I'm going to go onto another sheet of paper. For a right triangle, whether it's like this where they're equal, or if it's more like this, these acute angles here and here are complementary, and so are these. Okay, so complementary angles add up, add up to 90 degrees. Okay, and we can show that because we know that a triangle, if we add up all of the angles, they equal 180 degrees. So if this is 90 and this is 90, that means that when we add these two together, they have to equal 90 degrees because 90 and 90 is 180. So this and this would have to be 90, and they are. They're 45 degrees each. And 45 plus 45 equals 90, and 90 plus 90 equals 180. Okay, same thing for a right triangle that has like a longer leg and a shorter leg. If this angle is 90 degrees, again, we have a triangle has 180 degrees for all the angles. If one of them is 90 degrees, that means the other two have to add up to be 90 degrees. When two angles add up to be 90 degrees, that is the definition of complementary angles. Okay? So you could have, let's say this is shorter. So this could be like 30 and this could be 60. Those are some pretty common degree measures for right triangles. They're not all that way, obviously, but a lot of times when we're working in geometry, we will be working with 90, 45, 45, or 90, 30, 60, or 30, 60, 90, however you want to say it. Okay, so that's the basic gist of this lesson, and I'll see you for our next lesson.